This presentation will show you the type of equipment that you will find in a WCSS spill response unit and how to deploy that equipment. The video is a supplement to the WCSS awareness booklet. The type of equipment you will see used is typical for deployment in an initial spill response. First responders will likely use what they have on hand for equipment or deploy the co-op area's initial spill response unit and call for backup and specialized equipment as they need it. Also, the WCSS has regional equipment and a host of specialized equipment that is available to its members as well. Before you deploy equipment in a river channel, find a site that is best suited for containment and recovery operations. On a large river, you may have to use a combination of assessment approaches that include flying the river, consulting with locals and regulators, and using maps and technical data. Remember, a control point identified on a map might not be the best location to deploy your equipment. Ideal conditions for successful containment and recovery operations are in river conditions where there is a slow current, one that is less than 3 kilometers per hour, and where there is flat, deeper water with reasonable access. Some good advice to consider? Plan ahead. Know where your access points are downstream of your facilities and pipeline crossing for a spill response operation. After you have identified your site, implemented the site safety plan, have the responders and equipment ready, here are the typical steps to contain and recover hydrocarbon on the surface of a small river. The typical procedure of equipment deployment starts by planning the location of the equipment. First, the skimmer location is determined so that oil can be collected safely and pumped to storage facilities on shore. Then the boom angle is determined. This angle allows the spilled oil to be deflected along the boom to a recovery device. The rule of thumb is the slower the water, the more angle you can take. Never exceed more than a 45-degree angle. In fast water, more than 3 kilometers per hour, do not exceed more than a 30-degree boom angle. Prior to deploying the equipment, responders should develop a schematic of the deployment site that is reviewed with the work crews, showing the location of the skimmer, anchoring points, and boom angle, as well as the warning buoys and signs. First, set up warning marker buoys and/or floating signs upstream and downstream of the deployment site. This will serve to warn any river traffic that there is a hazard in the channel. These warnings should be half to 1 kilometer from the equipment deployment site. In larger rivers, it's common to have a boat crew dedicated to responder and public safety. The second step is to identify a strategy to anchor the lead end of the containment boom. One method normally used on large rivers is the use of in-stream anchors. WCSS typically uses a variety of in-stream anchors available to spill responders. The Sarka anchor, the rake anchor, and the Danforth anchor. It's important to have a good length of heavy chain, no less than 16 meters, on the shaft of the anchor. The anchor will need to be set on the river bottom before the boom is connected. The chain is connected to a rope hooked to a marker buoy that is the anchoring point for the boom. Make sure to set in-stream anchors in the channel in a location that ensures when the boom is connected to both the anchor and skimmer, there is an appropriate angle of the boom string to the current. In larger rivers, we would rarely exceed a 30-degree angle. Trolley lines are the preferred anchoring method. However, you need the containment site restricted to authorized boats only, as the technique calls for a line to be deployed across the entire channel. The rope trolley line is deployed on an angle to the channel with the high point located on the same side of the river as the boom hookup. Each end of the rope is anchored to a tree, drive-in pins, or other structures. Once the trolley line is installed, responders place a split pulley on the line that is used to connect the boom. Lines are connected to the split pulley so that the boom can be deployed, adjusted, or retrieved. On smaller rivers, it may be possible to anchor from both shorelines with drive-in pins or other anchors and still achieve an effective boom angle. In some cases, it's also feasible to utilize a bridge pier as an anchoring point with the use of a bridge pier bridle. The next step is to connect the boom to the anchoring point. Remember, the faster the current, the smaller the angle of the boom to the current. The boom has to be as straight as possible from the anchoring point to the connection on the skimmer. The standard oil spill fast water boom you will find in most of the response units is in 16-meter sections. It has a cable along the top tied to the connectors for strength and a chain that runs along the bottom of the boom to provide ballast. On each end of the boom is a 30-centimeter ASTM connector, often called a chicken grip connector. It is connected to the next section of boom with 2 pins. When the boom is floating in the water, there is 15 centimeters of draft and 15 centimeters of freeboard. There is provision every 3 meters on the boom for handline bridles used to assist in keeping the boom string in a straight line to the skimmer and at the proper angle to the current. WCSS has other types of booms available to its members. These include the inflatable fast water boom, the lake boom, and the shallow water boom. The inflatable fast water boom has the same dimensions as the standard boom. The lake boom has 30 centimeters of draft and 30 centimeters of freeboard. The shallow water boom floats with 7.5 centimeters of draft and 7.5 centimeters of freeboard. In shallow water conditions, the shallow water boom is often supplemented with water gate dams, inverted weirs, and Turner Valley gates. Other barriers that have been used include aqua dams, filter fences, and straw dikes. In some cases, you may be able to use straw, dimension lumber, or other materials you have on hand to contain oil before the response unit arrives on site. With the boom now in place, it is connected to the weir skimmer. The weir skimmer found in WCSS response units is called a Pedco skimmer. The unit is 0.66 meters wide. It consists of flotation with a trough that pivots based on the amount of suction applied, which is controlled by a ball valve on the discharge side of the trash pump. There are ASTM connectors on each side of the weir skimmer, where both the main string of boom and a 16-meter of shoreline boom are connected. Oil migrating down the boom is essentially contained in the V pattern and recovered as it enters the skimmer. It's designed to be used in surface water with a current and is not overly efficient in terms of separating the oil from the water. This skimmer also requires at least 60 centimeters of water, so the trough floats freely. If possible, responders should attempt to have the skimming operation in still water, where a drum skinner can be used to recover oil either on its own or in conjunction with the weir skimmer. WCSS have a number of drum skimmers available to its members. These skimmers are hydraulically driven and normally come with interchangeable drums, brushes, and in some cases, discs. WCSS also owns an advancing skimmer mounted on a jet boat. This bow skimmer is designed to advance into an oil slick and recover oil on a rotating oleophilic belt. Connecting the skimmer to the pump is the next step in the deployment process. The suction hose on the back of the skimmer rests on a hose float and is tied into a trash pump. The ball valve on the discharge side of the pump is used to adjust the angle that the lip of the weir skimmer sits in the water. When necessary, a line is connected to the hose float or on the back of the end of the skimmer to help pull the boom and skimmer in a straight line. The discharge hose from the pump is connected to a manifold, allowing the recovered fluid to be directed to a recovery tank or recirculated upstream of the skimmer. After the primary recovery system is in place, the spill responder should install secondary recovery just downstream of the primary. This will recover any product that escapes. Secondary recovery can be an identical system as the primary and/or sorbent boom, straw boom, or a variety of barriers or filter fences. Information linked to the WCSS resources and other training opportunities can be found in the WCSS Oil Spill Contingency Manual and on our website at wcss.ab.ca. If you have any questions, please contact your training facilitator.